It was a great lead-in to have him go before me because you're going to see a lot of the same problem statements. I'm going to give you a lot more data because you can't have a CTO in your title and not actually show a lot of data for that to go together. I'll spell you from the architecture diagrams that we're actually implementing, but wanted to introduce myself of, why is Intel up here? Why am I listening to you at all? Yes, we do make silicon. Yes, we have manufacturing. When you look at smart manufacturing, we will be one of the largest IoT in smart manufacturing implementation. So eating your own dog food, my team is out there, right, trying to install sensors. Having worked in MEMS sensors, I heard somebody talking about MEMS earlier, we actually have electrical and vibration sensor products that come out of my group. We sell a full end-to-end solution that is called Trend Analytics Software. It does more than trending, but marketing. Names will be changing soon. But it is a full energy monitoring solution and doing load disaggregation on HVACs today, looking at efficiency. So it's taking Intel's gateway, hardware gateway at the edge, our software stack, our analytics at the edge, our analytics in the cloud, hosted with Intel and Amazon, and our predictive maintenance analytics running in the edge. So it's acquired a company with a long-term experience in this that we've taken the software and essentially started to continue to develop and productize. And the goal of it is to actually go out and implement the solution. People can talk a lot about, oh, it's really hard, but trust me, when you're out there on a rooftop with Sam trying to hammer in a gateway with an electrical sensor and you're thinking, wow, we always think people are going to come update these things, and he just wants to know where the blinky light is. He's not going to replace the CPU when there's a problem. So it really gives you a lot into driving our products from what's really going to happen from every single person that touches the solution. So that's kind of why I'm here in terms of my team it is a software team with data scientists, like I said, but with hardware people, you do the full integration. So I kind of have a team of people that work with me, very, very cross-disciplined. The good news about where we are with IoT is that everything is becoming data. Right? As the world gets instrumented with sensors, everything every day is getting detected by cameras or audio, and things are processing it to turn it into data to send it somewhere, either to use it there locally or to send it to the cloud, which is good for data scientists and good for IoT. We like that. And I think most of you have seen this in lots of different versions of this chart, but it's essentially talking about how many devices are going to be connected by 2020, which there's varying, Salesforce says 75 billion, Cisco's largely it, since we're here, 50 billion for the connected devices. But you can basically see that it's going to ramp, significantly. And the price of the sensors, we were talking about sensors, and what they measure and come out with actually solving problems will drive how fast that ramp is actually going to happen. When you talk about, oh, the software needs to do something, and we went to install a sensor, the first thing we realized for vibration is brownfield. Okay, we were figuring out where to stick them. We didn't think the tape eventually was going to fall off, and the sensor would be giving us readings that made no sense because it actually wasn't attached anymore to the motor. It's hanging there, feeling vibration, so you're like, wow, that vibration looks weird now, but it's pretty consistent and still, well, it's not even epoxied to the motor anymore when you go out there. So it's like, wow, we should look at attaching too. That's pretty important when we go with these solutions, how they're going to attach to things. So, every single thing you go out and deal, you realize, wow, okay, that somebody would have had to deal with that. And they would be out here going, what's wrong with the data, and having to send people out to check it. So it's very interesting to go through and look at where those attachments happening, especially in industrial. And from full solution, what does it actually mean for every single piece in that system to work, from hardware to software to full end-to-end? And that's what we've been spending our time on. So I have a lot of interesting stories that I can share with you on that. The nice thing is that, with everything's about data, the thing is this is what our current kind of world looks like. We like to draw everything at the edge, except, of course, there'll be 50 billion of them. And it goes up into gateways and routers into the network and then into the cloud, right? Everything goes up. We have a very north-southbound view of the world, and everything's going to flow into a funnel, and then you're going to have smart applications that process it, and they do wonderful things, for us. In the world of talking to people, this isn't going to work. I'll show you the data why this isn't going to work, and it doesn't need to. So it's one of those things that it's endless possibilities, but this isn't necessarily what the world's going to look like, because the bad news is that everything's becoming data. It's a double-edged sword here. You're going to have lots of possibilities, but you have an avalanche, I think was the term used earlier, of data coming, at you. And we know for talking to customers, they can't already use the data they have. So you giving them big data, gigantic data, forget it, I'm not even listening anymore data. It's just sitting, idle, kind of, and they come over, tell me what to do with it. They really don't know what to do with it. So when you look at, it's great to have historical data and go do some operation on it, but it's not the silver bullet to solve the customer's problem, because you've got to have data scientists, you've got to do modeling, you have to understand what the data means. So there's a lot that needs to go in. They need help not only deploying these systems, but also analyzing the data up front. So the data scientists, I love them, deal with them every day, love data. They're the only ones. You get up there and you have mind-boggling slides that and charts that I look at, and I saw this the other day when he was talking. If this author, he did outliers, right? And this is exactly, I saw this and I started laughing because exactly, it doesn't mean you know everything, much less when you look at it actually made no change for doctors in doing correct diagnosis. It made them more confident. And I was talking to some of the colleagues at NSF yesterday. My sister's a doctor, and it is even worse when she's more confident when she's wrong than if she was less confident when she was wrong. So we want them to actually get correct diagnosis and be confident behind those diagnoses, not just have more data to be more confident about a diagnosis they don't even know is correct or not. There's a problem with this. It's great that they feel more confident, but we actually want the first part of it to be true. We want the correct diagnosis, right, to go up with more data. In that same article, he talked about, this came up earlier, is one, you've got more data, but looking behind it, there's a trust problem. Do you trust the data that you're getting? Because my favorite lead data scientist says, garbage in, garbage out. If you give me garbage data, I can give you garbage information back, and you can go do something that means absolutely nothing to go do, or is completely incorrect, right? And as you learn about people and you learn about, you don't necessarily right now know all the context at which they're making and they're forming their attitudes towards something. If you're doing consumer sales and things like that, you don't necessarily know some of that. And that's where some of the multimodal, right, taking a lot more sensors than just one. We have a view of, I'm going to take one sensor and now you have a Fitbit. I'm going to tell you how you walk. And that's not connected, again, not sharing data with, right, the other things about you and your, medical history and all the other things about you. There's, right now, it's very, single modal. We need to go multimodal. That gives you more context of what's the full picture of somebody's doing, right? And that takes the data sharing. So we have mountains of data that we're not using even from a single device, and now we're saying, wow, it's not as useful as it could be if you combine it with more data, but now you're getting bigger and bigger data, right? But the keys there is, it really could be useful. It could be useful, but you've got a big data problem, right? So in looking at those two things, you've got trust. Do you trust the data? Do you trust where it's coming from? Is it telling you what it needs to be telling you, right? Now you have one source. That's really not enough, right? So you don't quite have enough to trust everything. So this did not come out right on this slide. Imagine the X going up. Just because, we like to have interesting new fonts that apparently don't transfer. It doesn't really mean you know anything, much less know everything, just because you have more data. It could actually make it worse, not better, because you had more data, as I was mentioning. So my organization and my team is that it's actually about trusted, actionable intelligence. So you'll see me later talk about go from TMI to TAI. Talk about what can you give me that's trusted, actionable, and intelligence. And that's what we're driving our technology from when we look at our roadmap for hardware, when we look at our roadmap for software. Everything that we're asking for when we work with our solutions in IoT from our partners and at Intel is about trust and getting to an action point of analysis on that data, right? And as we talked about with multimodal, sharing, big key part of it. So you want to share, you want the information, but you want to analyze it so you don't send all the big data back. You want to get the action part out of it, as soon as you need to get the data out of it. So combining those two things, because that's the business value is what ends up why people deploy these things. They don't just deploy them for the sake of deploying them, because trust me, we go in and talk to them, and they're all really excited and they do absolutely nothing because they have no idea. We know how painful it is. We're doing it with them, but then they sit there with all this data and kind of go, unless so with IoT, you're really starting with, let's talk about their value for them and their business value. That's what's going to get it deployed. So it really starts with, you've got to show them, this is how the data is trusted, secure, here's how you're going to act on it, here's what you can actually do with it. And we spend a lot of time with that. I talked about the good and bad thing about data, right? This you've probably seen a lot. He talked about bandwidth in data and stuff, and you can see some of the scaling that goes on there and some of the numbers. But you can look that the amount of data going through, as he mentioned, I won't spend a lot of time on this, is just terrifying of how fast it's going up, right? How much you're processing. And data scientists, it's kind of already, as he alluded to, can't process as much data as it is. So we definitely have a big data problem, right? This is that side. This is the data behind that double-edged sword of it being great that we have data. The nice thing about being data scientists, because I get to listen to the tortured souls who said they had to sit and nobody cared about the data they were saying and they're running around with their spreadsheets that nobody can understand and weren't quite sure why nobody was listening to them, is now it's being proven that you're very important. There's money behind that, your value services, right, are going to be very important when we can figure out how to get value out of them for IoT. So it's, yes, we need hardware and connectivity, but you have to have everything on the right to get to the left. So it's something we need the hardware, we need the connectivity, we need all of it. But really the value is going to come out when you actually, as I said, when you're sitting in front of that customer and you're telling them what they can actually do with the data to targeted advertising. That means your sales are going to go up. Move your products around the store and retail in this way because look at your flow, your traffic for your customers. They're stopping in front of this area because you're selling Coke and that's a big product area, so it'll attract people to buy other things you may have on sale. It helps them actually start driving revenue in their store. When you talk to them about that, not about the fact they're going to get zettabytes of data, and I can tell you, it's like, I don't care. Their data scientists are very excited. I can't say that. Their data scientists are also very excited. But from the people making the decisions to deploy the systems, they just want to know, what's my value that I'm going to get out of this, right? So focusing on the value for the customers is the important thing. I wanted to show this a little bit is, of that zettabytes, here's what's going on with video and image versus sensor and machine data. This is important if you're a data scientist doing image and video recognition. Good job. If you're not, you might want to look into it. Video is going to be everywhere. Even parts of audio, we were talking about this. Pictures are getting uploaded every day. The amount of information and context you can get out of video and cameras compared to just sensing alone, is invaluable. If we'd had cameras running on that motor at the same time we had the vibration sensor, we would have seen it fallen off. And if we had video analytics running on it, it would have been the first thing that alerts in the same as the problem of the sensor fell off, everything from there. But again, we needed that other data input we didn't have. We have it now. We're actually doing remote gauge reading using a camera. So we didn't add sensors. We just are now translating all the analog readings off the dial from a camera into real reading, so the person doesn't have to go out there and read it. We're just doing it through a video feed, for example. So there's a lot going in, a lot of challenges around video analytics, but it's going to continue to go up as a very key part of IoT. And the challenge of turning that big data into small data, we talked about that. And as I mentioned, I like to joke with my data scientist, I really want small data, the actionable part of the data, because I need to do something in my everyday job. And that's the thing with big data is you think of this huge data center sitting there waiting to just, okay, run, right, on some massive set of data with your high-performance computing and run your simulation. Your marketing and everybody's trying to make money, how fast you're tweeting and how fast you're doing everything, trying to get you to buy something in the moment that you're walking by something, not 10 days later when, after they've run a simulation and go, oh, well, I should have, I would have got that customer. They want to know while you're walking through fast, what could I advertise if I had a digital display to get you to go buy that chips that I have on sale? Put something to get your attention, right? Scrape your phone, which we don't want them to do because we want our privacy. But the things you hear about people doing, they're trying to get you. It's really about small data. In the challenge, so again, back to the bad news, moving this thing, it's a massive amount of data, which we just talked about, right? It's going to cripple IT networks. They can't handle that much data. Our best friends here at Cisco, they're going to update the infrastructure, redo all the routers, but the speed at which that data is coming, that elbow, you can't keep up with everybody investing in the capital equipment to go replace all the infrastructure to move the data. So the comments about the edge are absolutely where the data is going. Our customers are talking to us about every single day about stuff needs to stay out on the edge because they're going over 3G. Oh, that's fine. You can have 10 megabits a month. How much did we just say a sensor is generating? And we get to send 10 megabits a month back because that's all they're going to pay for. They're missing a whole lot of information because they're not going to send it back over their network because of revenue costs. So multiple ways that things are really going to stay out, in that area. Plus, once you move it off that device, you're opening up security issues with that. So moving the data has consequences in multiple vectors, even more so than that. This, unfortunately, did a little wrapping too. Another challenge is the data access and interoperability. That is basically, 85% of the world is not connected, right, and has legacy today. So we're going to go out, like I said, we epoxied that sensor out there and started, sending it over Wi-Fi and processing data back. But Look at all the sensors. They're all different protocols. They're all different data formats. Everybody likes to write whatever code they want to write. That was a conversation going on in some of the questions of trying to share data when everybody's done their own thing. It's extremely difficult. But in looking at the world's business, the business world runs in English. If you go to Japan, they all know English because money flows in English. IoT, it's data. Money's going to flow in data. And there will be a common language for data. It just depends on how fast we work together to get there. And there will be common language that needs to be defined in medical, and there's common language in industrial. Are we calling the same thing? Oh, great, guess what? Now I don't have to go in and minutially know every single piece of your data for me to write software to integrate the data. Woohoo! We've got some registries with information, and we've all agreed that my data type is that data type, which you know what that is, or a new data type, and I just skip over it and go, I don't know what the heck that is until you come deal with it. Here's an API, go translate, recast your data, do the integration yourself. So there's things and challenges going on, but we know what we need to do. We need to create that language. One of the challenges too, so this is the same picture I showed you before, is, in the conversations you have with people, it's we like what we know. We like that, Google has a big data center, they own everything, the data comes back to them and it's theirs, When you look at the edge and fog, edge computing, you've got a lot of devices that are all connected to everybody's information that will eventually start sharing data directly between each other and not go back to a cloud, such as to Google's cloud. You've got trust now of data, even at that device, right? Because it's not provisioned on my network. I don't know, where that came from, and it's sending me data back, right, to me. So I don't own the physical location of all the servers anymore that I may be getting data from. So not only you're trying to share a language of data, but in that language, there has to be contracts. There has to be an idea of policies of trust, security, privacy, because you can secure the device, very important. You still want to secure the device. We have trusted boot in our silicon. We're doing everything at the hardware level. But once the data goes out into the wild, one, when you look at the millennials who don't trust it, they don't want it to go out in the wild unless they have control over it. Well, the only way you're going to control it is at the metadata level wrapped around the data that goes with it. And that we know that it came from that person as their data, right? And so the nice thing about connected worlds is you can poison pill data through metadata. You can have policies and things run by policy. And those are the things that we have to get to and start working together to define what those standards are going to be to make that language. And the government changes policies every now and then. So having something we can dynamically handle policy is going to be very important. So we've really got to get out of our old thinking that it just can't be done because it's difficult, but we definitely need to do it. So more data isn't always better. We really need it to be useful data. So small data, trust, give me some context of what I'm looking at here, multimodal, secure, privacy, basically everything I was just talking about. Kind of a little summary here on what's going on with the fragmentation. So we need to look at intelligent platform frameworks. They really need to think across all of these vectors to solve the problem, because picking one is great, but you've got to actually think, if you're going to think about an architecture that solves a problem, across these, because there's implications to choices you make that could limit any of these at any given time. So we're talking about AI, but I call it something different, ambient intelligence, right? Is that, let's say this is running and we won't call it Skynet, but we'll call it something else. I haven't thought of a cool name yet. But it's, we want to go from, like I said, TMI to TAI, right? It understands context. You start putting in the policies of who you are around your data. It knows your data policy because you've set different levels of policy for your data that, that company can see everything about me, but that company can only see my name. So, the good Intel silicon stamps out that data field, so even if they'd want to look at it, it's garbage anyway. They wouldn't know what it is. We've enforced that for you. Whatever policy you've implied, there's software that actually helps you, enforce that. And look at, we went ahead and put a blockchain on it for provenance, so you can actually get paid for it. So we're gonna track it and give you money for your data so that you have access to it. We're gonna tell you who actually used your data and touched it. So if you have trust issues, because we discussed millennials have trust issues, which really surprises me, because of the amount of data posted on Facebook and stuff that they have trust issues. It just doesn't make sense to me. Which is not the case. True. I think there's two sides to everything, right? There's two sides, because I definitely know from True, but I can tell you from a single woman perspective, not many of them will use Uber, there's trust either way, right? it depends on the person and everything. So, but from conversations that even in companies trusting each other, there's a lot more coming up of, Google started with do no evil, and the same thing is starting to trend of people looking at their data, kind of realizing the value in their data and saying, I want some control over this, some level that they're using it, not selling it and reselling it. I bought something and I get horse magazines. I don't own a horse. I have no idea how I started getting horse magazines. I don't know what I bought that triggered somebody to sell. Like, my best friend owns them. I'm like, oh, here's shampoo. I don't know why they're sending this to me. I do have a mane, but it's, not something. I actually tried it. It was very interesting. It's very soft, but it's just, my hair isn't coarse enough. The horse hair is very, very coarse. You learn these things. It's like, well, they sent it to me. Might as well try it. See, TMI, right back there. But actionable. So I'm not sure to tell you what not to buy, but you may end up getting horse shampoo at some point. But what we're looking at is software-defined IoT, right? Let's start getting out where if you're connected, we can actually make updates to the software. Start looking at FPGAs. Start looking at defining those trusted clouds. Staying at the edge for that data security, for taking care of that data volume. Look at it's the distributed. I think you guys know most about fog. Look at things being smarter, context-centric. I know content-centric networking is very big, but this is more about context. So leaving the data where it needs to be because it doesn't need to go anywhere else in the context it's being used. So how you start forming those relationships, and you can see most of those connections between those are the APIs. So we talked about APIs, so we do need to have API standards. Data does need to flow, between those. And the policies say where this thing goes, right? Who can see it, who has access to it, what fine-grained data, higher-grained data, who gets what, right? It's all a policy-driven implementation. That's the smart part, right? You design with policy in mind, and that's the architecture we're looking at and enforcing. So you can read some of the list of attributes that we're looking at here, but really going and changing the architecture from one direction to multi-directional, multi-dimensional, dynamic, moving things around, sensing if you don't have bandwidth, and moving things to compute where it does need to, but make sure you hit the latency. You're not going to move a real-time control on a heart valve over to run, right, on the server sitting next to you for no reason, things like that, so that intelligent side. Real quick, in looking at these standards, I'm one of the chairs for the data interoperability group for NIST. We are focused on, we know these data types, all the problems that I just talked about. We are working on this interoperability framework, looking at smart objects, and defining what those need to be, what are those sets of definitions of defining an object. So I'll show you some examples of types. And then that gives us better data fusion, right? That gives us the ability to multimodal. That gives us, right, ways to play with that zettabytes of data, and make it useful. And this is something we can do today. So the root of the root is that we really need to be able to share data and start talking the same language. I'm not going to read this to you. This is just, it was to give some formality around the architecture we're looking at. It has been published. It is out by CNRI that we're doing some prototypes with. You can find this out published on the web if you search for DOA. Very bad acronym. I don't know who didn't realize it stands for Dead on Arrival, but it was one of those things that it definitely sticks in people's mind as you look at an architecture, as extensible architecture. So we're working to try and move that as a standard. It really is meant to be, as you can see, scalable from a flexible element perspective. We're looking at everything has a name, almost as you would have a name. It has an identifier. It can be anything, right? An object can be anything. You just have to define in a registry that people can see what is my object and what does it mean, so people can know how to handle your objects, how to handle your definitions. What are you doing with it? You can hide different parts of it, right? It can be anything. And that's what we're looking at as part of DOA, and the other part here, DOI. And it gives people a lot more, as you can see here, a distributed DNS, if you know a lot about DNS and the issues there. And we're looking at it for enforcing and using for broker services. I just talked about policies, looking through and seeing who has read-write access. Can this go where it needs to go? How do you create that cloud where it doesn't cross geo boundaries, where there's a broker, right? That AI that I'm talking about sitting there going, yeah, that's not going across that country boundary. So this is my summary, and you can look at, I want to give you this example, because we took our predictive maintenance product and went through this example of you have a manufacturer in one country, they're going after a new market in another country, they've outsourced their repair of the equipment to a company from another country, and started walking through how is the data, because if users have different access to physical equipment, logical equipment, the data going across country boundaries, different policies between them, I think we made it the first 4 hours and we had to take a break and everybody went to the bar. I was like, oh my God, never mind. They go and store it in their file cabinets and leave it alone because this is going to be really hard. So we do really have to. It is an extremely difficult problem, but in order for us to have this world market, for interoperability, it is something from we're going to have to design with policy. We're going to have to design for data movement. We're going to have to take these really gnarly, complicated, cases and start working through them of getting that language put together. So that is the data movement as far as from what we're working on at Intel.